Today we will discuss about how to write a Matlab program for plotting a signal which is shown in A and the time duration is 0 to 10 seconds, and also in B, C, D, E and F. In the F part actually we will record our voice and see what is the spectrum of it. And the frequency that we are using for the signal which is mentioned is F equal to 300. Okay, so let us start. We will first open the new script. Then if it is opened, you will get a new window. In that new window you can type the program. I have already typed the program, so that you can see the first part is the clear screen. Okay, so it is clearing the screen, clear screen. Then it is clear all, it is will clear all the variable, close all, it will close any figure whatever it is opened. Then F equal to 300, and according to the Nyquist criteria we have to select the sampling frequency which is 20 times the frequency of the signal, then TS which is 1 over the sampling frequency. Then we have to define the time duration, and also we have to define the negative axis because our signal is changing from 0 to 10 seconds. So but since we need the negative axis, that means from -10 to 0 seconds also, so we have to take it. Okay, then we need from up to we need up to 10 seconds. So let us consider what is this. Okay, then you see we can see that Tn, the first value is 1, so Tn, sorry for this, T underscore n is the negative time axis. Then T is starting from the first value is T of 0. Okay, so we need the complete negative axis, or we need the complete complete positive axis. So we don't need actually 0, otherwise the 0 will be overlapping. So we need up to this 2. Okay, so let us now see what is the value of Tn. So Tn is up to 0.002. The next sample will be 2. Now we have the total time duration, that means the negative time as well as the positive time. Or else, okay, you can use like this. I have already used this from 2 to end, so you can use from 1 up to 1. So there is no issue. Otherwise the value 0 will be repeating 2 times. Not to avoid, we have to do like this. Then first value and the last value has been stored in T1 and T2. It will be helpful for us in convolution. Now we have to define our signal X. Since there is nothing, this is the signal completely positive sided because it is having u of t. We have to include zeros on the negative side, and from 0 onwards actually we have to start the positive side. Okay, that means we have to add so much number of zeros, that means up to the length of Tn minus 1. Why minus 1? Because we have to avoid the 0th sample. Then we have to plot it, okay, by using T total. So this is how we have to plot the signal. Next, u, the signal u actually u1, let's say u1. So what is that u1 actually? The signal u I have to define first, then we will see what is u. U means it is starting from 0. That means on the negative side everything is zeros. Then at 0, at time t equal to 0 onwards, it is having the value 1. Okay, then we have to take minus, then we have to time reversal. This is how you are doing the time reversal. So this is time reversal. Okay, then you have to plot it by using the total time and the y. Okay, the signal y. Next is you have a new signal which is x plus y. You take x from the top here and y from here and just add it and then plot it by using these comments. After that you can find the convolution p is equal to, that means in the question it is p is equal to convolution of x and y. So how to find it? For finding the convolution, you have to define a new time axis. The convolution can be easily found by using this method, okay, this command, and it is nothing but just the convolution that you have studied in discrete time. So in the same way it is performing. Now you have t new axis you have to define, because you know that after convolution the time axis will be elongated. So the time of axis, actually it will be having the lower limit gets added and the upper limits also will get added actually. So it will be increased, lower and upper limit will be increased. Since we have the time duration from t1 to t2 for both the signal, so our new time duration will be 2 times t1 and 2 times t2 with the same sampling time, okay. Then we can plot with the new time axis. Then also we have to find what is the time reversal. Now we are going to find the even part of the signal p. To find even part, we need to first reverse in time. This is how we are reversing in time. We will put the last value in the first and the first value in the last. That means end -1. We have to go in the opposite way. That is why it is -1. So this is how the value is taken. After that, we will add p reversed and original p, so that we will be add together and divided by 2. Then we will be getting the even part. So we can plot it by using the same command and it according to the new time axis. Then p odd, we have to take p and p reverse, that means p minus p reverse divided by 2, then plot it. So this is how we are performing this task, okay. Now I am going to run it. Let's see what we may get, okay. So you see here the first one, we have the signal e power minus xt, which is starting from 0. Then we have a step signal. Actually we have a signal which is time reversed step signal with the negative amplitude. This is what the second signal. Then we have the third signal. These two signals get added, so the 0 plus -1 will become -1 and just added, okay. Then we have found the convolution between the signal x of t and y of t. You can see this is the convolution between x of t and y of t. Next we want to extract the even part of this signal. That means take the signal, time reversed, then add it. You are getting the even signal. You see here, this is the even signal. Next we want to get the odd part of the signal. We are getting the odd part of the signal by using the method. This is how we have to do. The next part is nothing but we have to continue this simulation. This is for the audio recorder object. By using this object, actually we can create this is a set of programs which will read the data from the microphone. Then it will show first start speaking, then end recording, okay. So then it will play it. Then you can get the data from this object, then plot it. You can retrieve the what is the sampling frequency for this recorder. According to the sampling frequency, you can find the time duration. Then you can define a new time axis. Then you can define the nearest. Suppose when you define the time axis, for this I am actually recording for 2 seconds. This is recording for 2 seconds. You are getting the sampling frequency is actually 8,000 samples per second. So you will be getting something like 16,000 samples for 2 seconds. And we want to, for FFT, we need the sampling rate as the sample number of samples as n, which should be the power of 2. So the closest one for 16,000 is 16,384. So by using this will be the number of FFT points that we'll be considering. Then by using that, we will take the FFT of our signal, okay. We'll take the FFT of our signal, then plot it, okay. Then we will plot the magnitude spectrum. So I am going to simulate this. Hello. Actually I forgot to speak, so there was no signal at all during this duration. So let me run it again. Hello. Yes. Hello. Now I speak like now I just created the voice. Hello. two times, you see it has been recorded, and finally I am getting what is the frequency content in that. Okay, so this is actually the sampling number of samples actually. So this n doesn't show the actual frequency, but if we can convert it into the actual scale by using some manipulation. So anyway, I think this is clear to you. Thank you.